Bismillahirrahmanirrahim. Assalamu alaikum students. This is Muhammad Zishan Ahmad again from SLS Montessori and School. In our previous two videos, we studied theorems of chapter number 15 and now I will explain you the chapter number 16. So first theorem of chapter number 16 is parallelograms on the same base and between the same parallel lines or of same altitude are equal in area. You can see the diagram that we are having two parallelograms. This is A, B, C, D. One parallelogram and the second one is A, B, E, F with two conditions. That the first one is same base. You can observe both parallelograms have same base, that is AB, and second one is between the same parallel lines, that AB and DE, these both lines are parallel. So now what is given? Two parallelograms ABCD and ABEF having the same base AB that I just told you people between the same parallel lines AB and DE. What we have to prove, this was written in the proof, in the statement, sorry, that are equal in area. Both parallelograms are equal in area. So what we have to prove is area of a parallelogram ABCD. The first parallelogram, this is A, B, C, D, and the second one is A, B, E and F. So area of a parallelogram ABCD is equal to area of a parallelogram ABEF. Now, okay students, we move to its proof now. If you look at this figure A, B, C, D, actually this is a parallelogram. If you observe, this is the sum of a quadrilateral A, B, E, D along with triangle this C, B, E. And similarly, if you look at the parallelogram A, B, E, F, this is also the addition of the sum of the quadrilateral A, B, E, D along with triangle D, A, F. Now we observe that quadrilateral, this quadrilateral A, B, E, D, this quadrilateral is the common area, common region, which is the part of both parallelograms. So we just have to compare this triangle with this triangle, that I mean CBE triangle with triangle DAF. On comparing both triangles, we see that this CB is equal to DA. How? Because these two are the sides, opposite sides of a parallelogram. Which parallelogram? A, B, C, D. So these are equal. Now this is BE. BE is equal to AF. Why? Because these are also the opposite sides of a parallelogram A, B, E, F. And the third one, that we are making the angle, this angle CBE is formed by joining the sides CB and EB, and angle DAF, which means this angle is being formed by the joining of two lines, those are DA and FA, and these all the lines are congruent, so these angles will be congruent. So from side angle side or side angle postulate, both triangles are now congruent. In the figure, we were having a common quadrilateral region in both parallelograms, and now both triangles are congruent as well. So area of triangle CBE is congruent to area of triangle DAF, and hence now we can say that area of parallelogram ABCD is equal to area of parallelogram ABEF. Now we study theorem 16.1.2. What does the statement say? It says parallelograms on equal bases and having the same or equal altitude are equal in area. In the diagram, we are having two parallelograms A, B, C, D, and the second one is E, F, G, H with two conditions. First is that their bases are equal. It means BC is equal to FG, and second one is they both are in between the same parallel lines. It means this BCFG is a line which is parallel to ADEH. What is given now? Parallelograms ABCD EFGH are on equal bases BCFG and having equal altitude. What is to be proved? This is given in the statement that parallelograms on equal bases and having equal altitude are equal in area. So we have to prove again what we proved in 16.1.1 is area of a parallelograms ABCD is equal to area of a parallelogram EFGH. What is now construction? Place the parallelograms ABCD and EFGH so that their equal bases BCFG are in the straight line. So we placed both parallelograms such that their bases BC and FG are in the straight line. BCFG join BE and CH. So we have joined B to E and C to H. So we are going to proof is not so difficult. It is written that the given parallelograms ABCD and EFGH are between the same parallels. This is A, B, C, D and E, F, G, H are both the parallelograms are between the same parallel, as I told you earlier that this BCFG is parallel to ADEH. Hence, ADEH is a straight line and parallel to BC. Now BC is equal to FG. This is the BC and this is FG. These both are equal. Why? Because theorem is given in the statement we were given that the both bases of both parallelograms are equal. Further, this FG is equal to EH. Why? This is FG and this is EH. These are equal because these two are the opposite sides of a parallelogram. So opposite sides of a parallelogram is are always equal. So FG is equal to EH. Now this is BC equal to FG and this FG is equal to EH. It means BC is equal to EH like this and they parallel. Now BE and CH are both equal and parallel. Hence EBCH is a parallelogram. Why? This EBCH, why this is a parallelogram? I told you that, just told you that BC is equal to FG and FG is equal to EH. It means this BC and EH are equal and they are parallel as well. And we have a theorem that any quadrilateral with two opposite sides and parallel sides is always a parallelogram. Here, a quadrilateral with two opposite sides congruent and parallel is a parallelogram. So we can now say that EBCH, this is a parallelogram. This all was the step 1. Now in the step 2, first we compare parallelogram 1 with 3, that means parallelogram A, B, C, D with E, B, C, H, and then we will compare parallelogram 3 with 2. First we are comparing 1 and 3. If you look at these parallelograms, this BC is the same base. That is we can say that this is common base of both parallelograms. And according to the theorem of 16.1.1, first theorem of chapter 16, we can say that two parallelograms with same base and between the same altitudes are equal in area. So we can write area of parallelogram ABCD is equal to area of parallelogram EBCH. What is the reason? That I have just told you, being on the same base BC and between the same parallels. Now if we look at the figure 3 and figure 2, this EH is the common base. This is a parallelogram EBCH and second one is EFGH. Here in both these parallelograms, this EH is the common base, is the same base. So again, by the theorem 16.1.1, we can say that area of parallelogram EFGH is equal to area of parallelogram EBCH, and the reason is same, that being on the same base. Now base is EH, this one, and between the same parallels. From these both equation 1 and equation 2, if area of parallelogram ABCD is equal to area of parallelogram EBCH, and area of parallelogram is EFGH is also equal to area of parallelogram EBCH, if we look at these both equations, the right hand side of both equalities are same, which means their left sides will also be equal. So area of parallelogram ABCD is equal to area of parallelogram EFGH. So this has been proved. What does the statement of this question say? Show that the line segment joining the midpoints of opposite sides of a parallelogram divides it into two equal parallelograms. We are having a parallelogram A, B, C, D. The midpoint of AB is L and the midpoint of CD is this M. We join L to M. Now we have to prove that A, L, M, D, this is a parallelogram, and the second one is L, B, C, M. These both parallelograms are equal. We need to prove this. What is given? A, B, C, D is a parallelogram. L is the midpoint of AB and M is the midpoint of DC. To prove area of a parallelogram ALMD, this is ALMD is equal to area of a parallelogram LBCM. This is LBCM. Okay, moving to the proof. As AB is parallel to CD, this is AB. This is AB and parallel to CD. Very simple reason that as we know that ABCD whole is a parallelogram, so these are the opposite sides, and opposite sides of a parallelograms are always parallel. And AL is equal to LB. What is the logic behind it? The reason is that L was the midpoint, as we said in the given, that L is the midpoint of AB, so AL is equal to LB. Now since AL and LB are two equal bases of a parallelograms, this is AL and this is LB. Here we said this, these both are equal and in between the same parallel lines, so area of a parallelogram ALMD according to the theorem of 16.1.2 second theorem, area of a parallelogram ALMD is equal to area of a parallelograms LBCM, because this is the parallelogram first, this is the second. These both have equal bases and in between the same parallel lines, and we have proved this theorem in 16.1.2 that such two parallelograms with equal bases and equal altitude are equal in area. Okay students, in the next video we will explain Theorem 16.1.3 and 16.1.4. Take care of yourselves.